Hello, Korea and IDG. It's a pleasure to be here. I'm Fay Arjomandi, the founder and CEO of Mimik. I'm here to talk to you about IT and business innovation with edge computing trends and share some of my views with you. We are transitioning from cloud services to hybrid edge cloud services from technology point of view. Which is driven by a transition from mobile internet era to the hyper-connected world era. Mobile internet is about mobile connecting to cloud where content is hosted in order to consume content, which then led to a lot of over-the-top messaging applications and the first generation of digital solutions. But according to IDG, only 20% of industries have gone through the digital and cloud journey. 80% are about to go through that digital transformation across all industries. This was accelerated by orders of 6 to 10 years, according to some consulting firms such as Deloitte, due to COVID-19. Now, think about the cloud today and the amount of data centers that are serving the 20% of industries. And now think about the amount of data centers that need to be built. Should we continue with this cloud-centric application architecture and the infrastructure architecture for the next 80% of industries? The real estate cost, the cost of infrastructure to build data center, the cost of bandwidth to these data centers, and also the energy, the consumption and carbon footprint. These hyper-connected world is driven by the 4 key trends of a smart mobility, robotics, blockchain and AI. And the difference between hyper-connected world and the mobile internet is that, as we discussed, mobile internet was about consumption. Hyper-connected world is digital intersection with physical aspects of our lives. So the digital is around us, and the digital solutions need to really mimic the physical interactions. So it's no longer about centralized world, but it's really about a decentralized world. And the question is that is the tsunami of the connected devices that due to Moore's law is going to continue growing with more power, more CPU, and thanks to connectivity such as 5G and Wi-Fi connectivity everywhere. The second thing is that these devices is not gonna be just consuming content, but it's about producing information. And when you think about a hyper-connected world driven by HoloLens, robotic type applications, AIs, and smart mobility, every device, every application need to communicate with every other application. And you have to address time-sensitive issues. You have to address data security and privacy issues. And the other thing is that you can no longer think about vertical silos. You have to start thinking about platforms. You have to start thinking about services. So one thing that I definitely see and we believe in at Mimik is that we're actually at the tail end of app economy and entering the systems economy. It's no longer about Internet of things, but it's actually about Internet of systems. How do we address that? To address this tsunami, to provide a better platform to address all these concerns, we have to start thinking about how to utilize edge, how to utilize edge cloud computing. The challenge today is what is edge and where is it? And unfortunately, the market is in a little bit of a confusion frenzy of defining edge, and they're kind of constantly going across different terms of mist computing, device edge, near edge, hyperscale edge, far edge, and you name it. Every day the market is coming out with a new name. We believe that it's much simpler than that. We believe that if we look at cloud from one of the things that cloud did is provided the infrastructure that applications backend can now run over there, and it's provide resource. So if you start thinking about any hardware outside data center that has memory, CPU, storage, and connectivity, and a form of operating system that can run a client application, it's the first point for being an edge computing device itself, an edge cloud computing device itself. So it's about where data source is, there is also computation available that can process data and can translate data into knowledge and can create communication with other devices, with other application in an ad hoc form as the digital world surrounds us. So we believe that edge is really the device where the source of data is, and then you start moving from that device all the way to continuum computing available that is available on the way. For example, you may have a gateway that now has resource and can turn into a cloud server at that moment for processing a task. And then you have on-premise data center, and then you have regional data center, and then you have cloud. It's a fully decentralized model that starts from the device where the source of data is. So it's not about bringing computation closer to device necessary, but it's about first utilize the device resource and then start utilizing the other computation on the path. And why is that better? Is because compute is available where data source is. You can in a faster time, you can translate raw data to knowledge. You can exchange that knowledge with other applications within that edge, because a lot of time really where the event need to go from one device is to another device. Imagine a connected factory where you have a robotic car that now need to inform another robot to do an action. And then it allows systems cross vertical industry that we know it today to communicate with each other. Again, if you think about a smart manufacturing situation, you have a robot that now predict that is about to go offline because of the malfunction. That robot need to send a message to either another robot or a mobile workforce management application to dispatch a worker to come and do the manual work. So it's no longer the ability to confine them in the vertical is no longer there. It's basically you breaking the boundaries, and you converting the challenges of so-called cloud orchestration into choreography of devices, in an automated choreography of devices. So that's another view into that where edge and where cloud is. And the two will always coexist. But if you look at it, the bottom of pyramid is where you have more device, billions of devices that running tens of billions of applications, and they're connected, and they can be their own cloud server in order to create communication between the applications. And then you have the edge server providers such as Amazon Greengrass or Zedata and others. And then you have regional data center providers such as Fastly of the world. And then you have cloud providers that are coming to edge. And to name a few cloud providers that are coming to edge, IBM Cloud with their Open Horizon and Redshift, Amazon Wavelength and Amazon Greengrass, Microsoft Azure and Azure Zone. So on one side, it's about edge in, where the data source is, and then utilize any cloud computation as needed. Now, how would that work? How would that edge works? You really need to turn any device into a cloud server, and you have to look at it from a cloud driven or cloud native application development, which was about macro services, subsystems, small systems that define the RESTful API. And now these macro services can exist on these devices. The underlying edge cloud is about ad hoc formation of cluster of resource. So, and those ad hoc formation of cluster of resource can be based on network, connected manufacturing, all devices are connected to an open RAN, or as a smart home, all devices are connected to a home Wi-Fi gateway or a 5G home gateway. And now when you deploy the macro service on these devices, these macro services can now form an ad hoc service mesh amongst the device and with cloud when needed and when plausible. So now that's one type of cluster formation, and that's where the choreography come to the picture versus always orchestration, because when you have the knowledge on that device, and when the device knows, when the microservice knows where the other devices that need to send information to, then you have a choreography architecture versus always going through the cluster, through the orchestration. Now, one is about network cluster. The second one is about proximity, devices that are within vicinity of each other. Imagine when you are in a connected manufacturing and a truck getting close to the connected manufacturing, now that truck can inform the manufacturing that, hey, I'm getting close, and now you have the pallets that are coming at the door to get loaded to the truck. So now you, as the truck getting closer, you are within vicinity of other devices, and therefore you can exchange knowledge with. And then the third one is about account, any device that belongs to me as the end user. If I am in a smart home situation, or if I have 5 devices that they are not necessarily attached to the same network, and they may not necessarily be in the vicinity of each other. Let's say I'm here in Bay Area, and I also have an office in Vancouver, and I want to extract information or view information from my device in Vancouver, and they both have enough power and enough compute that they can host the content that is already resides there. Now, or it can be a collection of devices that belongs to an enterprise, and during the slow hours, those devices can participate in crunching data for that enterprise. Now, by doing this, what you're actually achieving is this notion of ad hoc service mesh, that they can work with each other based on the net being part of the same network, based on being part of the within the vicinity of each other, or based on being part of the same account or group of devices, that now you have a full ad hoc macro service mesh or service mesh, which is above the network layer, and they can communicate cross network, cross device and operating system, and cross cloud. Again, the two will always coexist, but information starts from the edge. Knowledge gets converted from raw data to knowledge, and knowledge can get exchanged amongst devices and with cloud when it's plausible. And imagine now in that context, from the device, you can decide, you can label the data, and you can send data to different destination. You can invoke from the device, you can invoke this notion of mobile edge computing, which means a base station that now I have within vicinity, and now I have a task to do, and I can invoke a resource from the telcos to now process the task, or I can go to my public or on-premise data center. So you really have full flexibility and agility to deliver solutions. So hybrid edge cloud, in a sense, enables and powers up the next hyper-connected world, which by orders of magnitude, again, if you think about according Gartner, is 80% of industry, and by orders of magnitude is larger than the mobile internet era. And it's important because from ground up, we can build solutions with much higher scalability. Imagine in a connected manufacturing, you want to decide the digital transformation. And now instead of investing upfront into hardware infrastructure, you already see that, okay, I have 100 robots that at least each robot can translate their own raw data to information. Therefore, I don't need to commit to much harder, much bigger upfront investment. It's much more private. It provides privacy of data. It can crunch. You can, even if you think about a simple task of privacy, it provides security. It provides interoperability because everything will be based on microservice-driven architecture and RESTful API. Therefore, as you go through as enterprises go through digital transformation and they realize that, oh, I need to now interact with another system, is another API calls, and another microservice-driven architecture. So it gives you the flexibility that needed and the agility to scale and develop application delivery. It provides peer-to-peer functionality. It's a path to zero carbon footprint because the device that is already in your hand, the robot that is already being powered, is the first point of being a cloud resource. And it enables a massive cost saving, again, in terms of infrastructure. Let's also go through one kind of another example. CCTV cameras for the data for the streets. Today, there is a lot of concern that we want to keep our streets safe from all kind of threats. But at what cost? At what cost for privacy of the neighborhood? And today, all these cameras are streaming data to a data center, to a NOC, and people are sitting from the NOC centers or monitoring the CCTV camera stream. And then if they see an event, they notify a law enforcement. This has created a lot of privacy concern for neighborhood, but at the same time is necessary. Now imagine in the world where we have every camera that it's its own edge cloud. Now when the law enforcement have a threat by a suspect or a car, within the cloud we can train the model of the plate or the facial of the suspect, and we can now push the model to the cameras. All the cameras are now checking the streets against the suspect, against the model that is on the camera. And when a camera sees a suspect, it can inform the other cameras within cluster of proximity. And it can also, you can input information in the camera that when you see the suspect, it's also informed such and such law enforcement. So now you have a fully distributed, decentralized, private system that can work autonomously, dynamically, with full privacy of information between the parties. You could even imagine that in a sense where we have surveillance camera outside our home, if an event happens, you'd be happy to let your camera be the eyes of a law enforcement at that moment, where you can receive information about the suspect in camera without being given to the user, and the camera can now watch for seeing the suspect or seeing the plate number. The same example of that, by the way, applies to your smart home solution. I personally have a father that is visually impaired, and I want to have a camera for his home, but I'm afraid of the digital intrusion. Now, having the ability that when my mom leaves home, she can trigger the camera to start streaming to me only. That is another example of enabling a function that can assist my parents, but at the same time is not a digital intrusion to their life. So, in a nutshell, this is what enables, whether it's an industry in oil and gas, it's energy, it's manufacturing, it's health tech, it's fintech, it's edtech, agri-tech, defense, and more and more and more, anything and cross these things is what will be enabled with edge cloud computing, and it's the trend that we're heading there. And this is necessary for creating a sustainable digital economy, for creating a systematic digital transformation, and for allowing enterprises to secure their future of their businesses, and it allowing many startups across all these industries to innovate much faster, at much lower cost, and it's creating a sustainable digital economy. It's creating intelligent workflow. So with that, I know I tried to convey a lot in this 21 minutes, but one thing that I have to leave with you is that really it's about creating ecosystem. It's about collaborating. It's no single company can do everything in this sector. It's really a formation of an ecosystem players, from the existing cloud providers to edge computing providers to application providers, and the market is now every day is a new data to be $23 trillion. But really, it's about the next generation of digital economy. It's been a pleasure, and don't hesitate to contact me with my email or any other means. Happy to answer any questions. Thanks for having me.